So hi everyone. Thanks to the user group for inviting me along to talk tonight. So today it's Azure Firewall in the real world. I've been using Azure Firewall with mid-large customers in Norway and the Nordics for 2.5 years now. And it's the only firewall that we actually deal with, because we're not partners with any of the third parties or anything like that. And our knowledge is Azure, not other stuff. We tend to deal with DevOps and DevSecOps, and Azure Firewall is kind of perfect for that. So I'm a Microsoft Valuable Professional, or MVP, non-minimally viable product. I have been for 14 years, previous to my current expertise of Azure. I actually forget how many years I'm on Azure. I haven't updated this slide in a while. I was a Hyper-V MVP for a long time, and for 1 year I was a config manager MVP. I do own my own training company called Cloud Mechanics. Haven't actually done any training in a year with that. I need to kick that off again. And I've been a principal consultant with Innofactor Norway for the last 2.5 years. And prior to that, I actually, for just over a decade, worked in the Irish partner community with Micro Warehouse, who's the kind of the dominant distributor in the Irish market, or indirect reseller, as they're now called. And I've been working in IT since 1996, consultant, sysadmin, technical pre-sales, all that jazz. Worked with lots of stuff, so Hyper-V, System Center, Windows Server, and if you're working in the cloud, by God, Windows Server is still relevant. And there's no getting away from that. And I blog on aidanfin.com, and you can learn about my employer at innofactor.com, my company at cloudmechanics.com, and of course you can find me on Twitter as @Joe_Elway, where I sometimes tweet about IT stuff, but there's a lot of ranting about whatever's annoying me at the time. And yesterday that was Azure PowerShell. So why would you need a firewall in the cloud? Well, let's just say security is good. Okay, so here's a couple of big name cases where people did not do security. Now they're on-prem cases, they're not cloud cases, but it's no different. Where you place the stuff doesn't really change the security conversation. Where you place the stuff can change how you do your security and make your security easier, namely the cloud. Because an awful lot of that responsibility is offloaded, but the stuff that you do at the network level and the application level and the identity level still is your responsibility. So we look at Norsk Hydro, they didn't implement good practices for network security. They got done by ransomware and lost about $40 million in a week. And of course, recently here in Ireland, we know that one person opened up an email they shouldn't have. Now, can't blame the person because it was probably an accountant who received something that said invoice or some junk like that. And they're used to receiving hundreds and thousands of those things on a monthly basis. And that shut down our health service in Ireland for a long time. And I think something like 80% of it is only back at this point. And that was what, a month and a half ago they got hit. So for a month, you couldn't get a blood test and stuff like that. And it's had all sorts of impacts, and we estimate that's over 100 million euros worth of damage so far. Most of that going to the consulting companies that are probably helping them out. Why are they getting hit by those things? Because they haven't implemented micro-segmented security. I'll talk about that in a second. And then the mistake number 2, and this is the classic mistake when you go to the cloud. The developers and the operators, they can do the security at the application. They don't have a freaking clue. Developers will make X turn into Y, and that's what they're good at. Ask them to come up with an algorithm, they'll write it. Don't ask them to make it secure, because that's not their skill set. Network security is not their skill set. Operators, the people who run your systems on a day-to-day basis, again, that's not their skill set. They're the sort of people that will create a file share, open it up to everyone on the network, because that gets the job done and that makes the boss happy. The fact that it becomes compromised afterwards, yeah, that's not their problem. An example of this happened in Microsoft, where a developer set up a database using Azure SQL, we believe, could have even been a SQL server, and opened it up to the entire internet. And it had customer support information in that database. They just left it open. Now you'll read about story after story like that online if you go looking for that information. It's not just this Microsoft developer. Why did he do that? Because it was easy for him to get at the database. He was probably opening up for Power BI or whatever it was, and he just made life easy. So didn't do the stuff that he should have done. And if you attend any Microsoft conference lately where they're talking about networking and security, they're going to use phrases like microsegmentation. Now, microsegmentation is where we implement the firewall in depth. We don't just put it at the edge. We've known since the early 2000s that edge firewall is just like the shell of an egg. And if you just tap a little teeny tiny hole in it, you're in. Ask Sony. What was it, about 10 years ago? They got done by some hackers in the UK, some teenagers, where they did a SQL injection attack on a MySQL database, and they managed to bring down Sony's entire gaming network. The hole had to be there. It's just they didn't secure it at the application layer. So we have to implement our security at depth, but we have to do it at the edge. And there's this big assumption that we go to the cloud and we don't need a firewall anymore. That's wrong. In fact, we need lots of them, and you need to have that central firewall. That's going to protect you for your north-south traffic and your east-west traffic. North-south going from the internet and from on-prem. We have to treat on-prem as dirty as the internet. That's where the client devices are. That's where Outlook is. That's where the web browser is. Those are two primary forms of entry for attackers onto your network. So you have to treat on-prem as dirty as the internet. So our north-south, that's inbound and outbound. If the HSE had filtered out the outbound traffic, the command and control for the ransomware that hit them would not have worked. And it turns out that ransomware is manually controlled. It's not automated. It has a certain level of automation, but it is manually controlled so it can stay under the radar. So a SIEM solution doesn't see this very noisy thing happening. It quietly sneaks around the place while a human controls it over a period of weeks or months. We also want to protect east-west. So that's between our workloads, whether they're in different subnets or even different virtual networks, if you're talking about a true enterprise scale environment, or a hub and spoke deployment. And that's because we don't want to be opening things up. Typical sysadmin approach is open it all up internally. How many data centers have you ever gone into where they've microsegmented the network? Maybe they've caught this concept of secure zones or secured VLANs, and what you'll find is everything's just open. Because it's easy, makes it easy for everybody. We don't have to figure out what the firewall rules are. And of course, good policy, turn off Windows Firewall. Because who wants that? You'll find third-party consultants coming in. You've got this lovely secure Windows installation. What do they come in and do? Turn off the firewall, because then they don't have to figure out the firewall rules of their own application that they're installing for you. So you need to harden this stuff in depth. Now, the thing I want to talk about is that thing in the center, thing in the hub, or your network core of the cloud. And that's the firewall appliance. In particular, I'm going to be talking about the Azure Firewall. So the Azure Firewall. Who wants to implement a Microsoft firewall? Anyone? Like 10 years ago, if I said to you, let's put in a Microsoft firewall, you probably would have laughed at me.
Yeah.
But these days, it's different. The Microsoft firewall is a very different sort of appliance. And the people who are developing that thing aren't the people who wrote the Forefront product set 10, 15 years ago. It's a very different set of people. These are people that Microsoft have acquired through purchases from the likes of Israel. When you think of security software, you think of Israel. Because that's where some hardcore security stuff is actually going on. And when you talk to these people, I do on a fairly frequent basis, you realize these are some very, very serious people with some big brains. And they really are going after industry standards and certifying their firewall an awful lot for various different standards. So this isn't the joke it would have been in the past. Why was I seriously interested in the Azure Firewall? Well, it's because it's a platform service. It's not a third-party appliance that basically runs in a VM that now I have to manage. This thing runs under the covers. Yeah, it's virtual machines under the covers. Everything is in platform, even serverless. All this whole thing about containers and all that, it's running in VMs under the covers. There's no such thing really as serverless. This is basically load balanced virtual machines under the covers, orchestrated, managed, scaled out, scaled in for you automatically. Single configuration made highly available across the environment. Stuff that if you were running out third-party appliances, you would have to figure out how to do that yourself, or do that, follow the instructions, if they exist, from the third-party vendor. So there's no maintenance of this thing, no upgrades. Single vendor support. If I'm having a problem with my networking, who do I go to? I go to Microsoft. I don't have to open up a support call with Cisco, God help me, and Microsoft. I can focus entirely on the security configuration of that firewall. That's it. That's all I've got to worry about. And this is implemented using Azure Resource Manager. Now, if you're interested in using Bicep, or Terraform, or Pulumi, or any of these different things, you can still do that. Or if you want to manage it through the Azure portal, you can do that. But for the big benefit from me is I can implement this using templates, namely my behalf, or in my case, ARM. So everything is code. That's code sitting in Azure DevOps. That's pushed out with a pipeline. And if a customer wants, they can make that subscription read-only. And maybe have some break glass accounts. And they have to manage everything through DevOps. So now we're getting into DevSecOps world. So Dev Security Ops. So I can edit my code rules, or my rules as code in VS Code, push that up to DevOps. Somebody can review it, approve it. That gets merged back into the trunk. And then the pipeline automatically rolls it out. Now, if something goes wrong, go back to the previous version. Pipeline rolls it back out. So I have my rollback. How do I document the firewall? I don't. It's already documented as code. How do I back it up? I don't. It's already backed up through DevOps. I can actually delete the firewall, rerun the pipeline, my firewall reappears. So it's kind of a cool solution. There's two ways we can deploy the Azure Firewall. The first is in a traditional virtual network. And this is referred to as the VNet deployment, or the VNet SKU. This is where you build a virtual network, where it's a single virtual network in maybe a point solution or small, medium business, or it's in a hub virtual network in a mid to large enterprise. So a hub and spoke architecture. This is sort of concept where you build a network core called a hub. That will contain your connectivity and your transit stuff and your security appliance. The alternative to that in the Azure world is the Azure Virtual WAN Hub. And this is what I've started working with about 6 months ago. Started experimenting with actually this time last year, and was planning for about 2 years ago when I started learning about some of the changes that were coming in Azure Firewall. And this is my preferred approach because this shoves the networking even further down the platform. So I have less stuff to manage, and in fact makes a lot of the routing easier because I can push the routing out from the Azure Virtual WAN Hub to my spoke networks. And even if I'm running an SD-WAN, I can push that routing out to my on-premises appliances as well. And I'll talk about why we might want to do that a little later on. And basically, it makes life even easier for this world. But functionality-wise, the firewall is almost identical. A couple tiny little changes, mainly around the public IP addresses. But for the most part, it's almost identical. The network it's deployed in, whether you can see it or not, it's deployed like in this slide. So there's a dedicated subnet deployed in your network called the Azure Firewall Subnet. You can't rename it. You have to use the name Azure Firewall Subnet. And the routing for that subnet, or the routing for the firewall, is dictated by that subnet. However, there is an exception to that, and that's when you're dealing with public IP addresses or non-RFC 1980. So traffic coming from on-prem must be routed through that firewall. So you have to control that. So if you ever have the pleasure of being interviewed by me and you happen to mention that you've worked with firewalls in the cloud in Azure, I'm going to ask you how you got your traffic from on-prem through your firewall. And if you can't tell me how you did that, then you didn't work with a firewall, whether it's Azure Firewall or a third-party firewall. And you have to force that traffic through the firewall. Same with your outbound traffic. So if you're doing a traditional hub and spoke, you have to be doing user-defined routes to manage those flows. That's basically how you do your cabling in the cloud. If you're doing virtual WAN, you're going to be using the hub route tables. And if you're working with PaaS, so things like API management, app service environments, SQL MI, and stuff like that in your subnets or your spokes, you're going to have to put in control plane overrides for those things, because they've got some communications that must go direct to internet and must bypass the firewall. And that's typically documented by the teams of those different products. Some better than others. The Azure Firewall is automatically highly available. So it automatically has scale out. Unlike some of the third-party firewalls where you either have to build that yourself or they don't even support it in the first place. There's even one brand, Cisco, that if you do HA, you basically have put a big bunch of TNT in the middle of your network and lit a fuse, and at some point it will blow up. So be careful of what vendors you may actually choose if you are going third party. What you see in Manage is basically this concept of a firewall that's going to have public IP addresses. It has some sort of configuration management, and it has a private IP address. Under the covers, there is a standard tier load balancer, and there's virtual machines, D-series virtual machines, at least 2. And if you choose to deploy it across availability zones in a region that supports availability zones, there'll be at least 3. And it will automatically scale out and in based on your throughput, giving you up to 30 gigabits per second of total throughput, much more than the third-party virtual appliances will actually give you, because they're limited in terms of how they can scale and the virtual machine capabilities, and then the software limits within those virtual machine capabilities as well. If you go with availability sets instead of availability zones, this is done under the covers again, you have a 99.95% SLA. If you're going with availability zones, you get a 99.99% SLA. I have not seen any downtime with Azure Firewall at all. I've seen a couple of glitches here and there, but I have not seen downtime at all. So the SLA is kind of like, yeah, it's great, but the firewall actually exceeds it. Right, the resources. So when you deploy it, you have 2 ways of dealing with the firewall. With the old way, we try to tell people not to do this anymore, which is they just deploy a firewall and that's it. They try to manage the firewall directly through the firewall. And the firewall will have certain features available to it, and then you can manage the rules within that firewall. Now, in the old model, rules are basically broken up into 3 categories. We have DNAT rules or NAT rules, so for inbound NAT. Network rules for dealing with non-HTTP and HTTPS traffic. And then we have application rules, which deals with HTTP, HTTPS, and potentially SQL Server traffic as well. And those are then stored in rules collections. So you can have a rules collection for dealing with NAT or DNAT, rules collection for dealing with network, rules collection for dealing with application. And you can have lots of those rules collections, lots and lots of them. And they either allow stuff, deny stuff, and they have different priorities on the collections as well. The newer model is where we, instead of managing the configuration of the firewall directly, we manage it using a firewall policy. And this is the direction that Microsoft haven't really come out and said it explicitly. They've hinted at it, but it was clear this time last year that they were basically deprecating the UI for Azure Firewall and steering you towards using this policy instead. And because the policy gives us a more interesting administrative model, and also means that they don't have to duplicate the administrative effort or the developer effort to maintain the configuration of the management in the policy and in the firewall. So what you're seeing is new features in Azure Firewall since July of last year have only appeared in policy. They have not appeared in the firewall. So if you've heard about things like IDPS and TLS inspection and stuff, you've gone looking for them in the Azure Firewall itself, they're not there. You have to be using policy, and you can transition fairly seamlessly from firewall to using firewall with policy. There is basically you can create a policy and you can point it at an existing firewall and it will import your rule sets and your configuration from there. Now, what makes it interesting is a couple of things. Yeah, there's the extra features in policy, but we also have a new way of aggregating our rules, and I'll talk a little bit more about this in a few moments. And this is where we can take those rules collections, which contain rules for either DNet, network, or application, and we can put them into groups. So it sounds like this is a complicated hierarchy, but you know what? When you're dealing at scale where you have lots and lots of workloads, and you need some way of identifying what rules are associated with what workloads, this starts getting to be useful. Also, if you're dealing with an organization that has many firewalls and has different people responsible for those firewalls, you have two layers of management to deal with. You may have the local firewall admin, but then you'll have, we'll call them the enterprise or corporate or the government firewall admins or the department firewall admins, who need to have oversight over everything and may have a set of rules that need to be forced on everybody. So in that scenario, we can create a parent policy, which has the configuration that everyone must have in their firewall. And then that is inherited automatically into a child policy, which is then associated with a firewall. Now, there's no chance for overlap or anything like that, because when you write into a parent policy, it is automatically writing into the child policies as well. So it's a direct edit. So when you go to save something in the parent policy, it is actually writing directly into the configurations of all the indirectly associated firewalls at the same time. And it's only if it succeeds that in all of them that it will be a successful save of the parent policy. Right, some of my observations. If you're going into an environment where you're trying to introduce Azure Firewall, and your biggest enemy in that scenario is going to be the firewall admin. And because they are probably certified at Cisco or Checkpoint or Palo Alto or something like that, and that's their baby. That's the skill set that makes them special. It's like when you go into a customer and you're saying, right, we're going to go to the cloud. Oh yes, SAN administrator, you're irrelevant now. That's conversation you're basically having, because when you go Azure Firewall, there's no easier firewall to learn. I can teach someone to use Azure Firewall in under a day, every feature in that thing. Where I can't teach you that with a Palo Alto or a Checkpoint or anything like that. Because Azure Firewall, it's all about the rules. In the end, that's what it's all about, is the rules and the security tools. It's not about all the other crap around it and how to upgrade it, maintain it, and all that junk. And it focuses entirely on what's important. Dealing with those firewall admins, they're usually quite political, they're well connected, it can get quite messy. I've been there, and it did get very, very messy. And dealing with that particular person I can think of right now. Other thing to think of is the biggest complexity with firewalls, not just the Azure Firewall, but any firewall in Azure, is understanding Azure routing. And I cannot understate or overstate this. And it's amazing how many times I've submitted sessions to conferences and stuff about Azure routing, and I've never gotten those sessions accepted because I don't think they understand how important this stuff is. Any of the troubleshooting I end up doing with Azure Firewall typically ends up being routing diagnostics, understanding why things are not getting to the firewall when they should be. And that's the most of it. And the routing in Azure is complicated. There's not many people who really understand it. There's loads of people who think they understand it. There's plenty of Microsoft documentation that claims to give people architectures and how to make the firewall work, or a firewall work, and it's wrong. I have written a very long blog post on my site about how routing works in Azure. And it's critical to be able to control the routing, to be able to get the flows through your firewall, whether it's Azure Firewall or a third-party firewall. And it's important that you enable a logging. Whether you're doing that to log analytics, which might opinion would be the best way to do it, or to a third-party solution, and you need to get that logging up and running, so you can see the information coming out of that firewall, and potentially out of your network security groups as well, and to see if the traffic is actually getting to the destination subnets. So firewall rules. And the Azure Firewall, its core function is filtering, and the main thing it will do is deny everything by default, inbound and outbound. If you do not add any rules, it will block everything. So you have the network rules dealing with non-HTTPS, non-HTTP, non-SQL Server traffic by default. It typically handles sources and destinations that are IP addresses, but that also includes fully qualified domain names that resolve to IP addresses as well. And we have application rules. Some of the Microsoft documentation will talk about, oh, this is what makes the Azure Firewall a layer 7 firewall. It's not really a layer 7 firewall. That's functionality that's handled in Azure by Web Application Firewall. But it does have some understanding of layer 7. So it deals with HTTP, HTTPS, and Microsoft SQL Server traffic. That includes things like Azure SQL and SQL Data Warehouse and stuff like that. In application rules, and then for traffic there where you want to do a port translation to the internet, then you can do DNAT rules. So this is where you can make some internal IP address available on the internet using a public IP address. This does not do Web Application Firewall functionality. If you want that, deploy Application Gateway or Azure Front Door, where you can add the Web Application Firewall functionality for your HTTPS services. And DNAT rules, when you enable them, they're basically processed as network rules under the covers, and that's done hidden to you. Those rules are then stored in rules collections. So we can have 3 types of rules collections. We can have network rules, application rules, and DNAT rules collections. The rules collection defines whether the traffic is allowed or denied. So the rules define the sources and destinations, the protocols and ports and that stuff. The rules collection, which contains those rules, defines whether it's allowed or denied, and then provides a priority. So the rules collections are processed in a particular order. And this is traditional firewalling stuff at this point. We've different types of rules collections, and therefore there is a processing order. So for traffic that's coming in to the firewall from outside world, DNAT is dealt with first, then network is dealt with. For traffic that is going from internal to outbound, network rules are processed first. And if the flow isn't found in the network rule, then it's processed in application rules. And that could be an interesting one when you're troubleshooting. So one of my colleagues, another Irish guy, wasted about 2 days trying to troubleshoot an application, an NPS server, or no, Radius server that he was configuring in Azure to provide authentication for Wi-Fi on the on-prem network. And he couldn't figure out what was going wrong. Couldn't see any logs in the application rules logs that indicated the traffic was being denied. And finally contacted me, and within 20 minutes I'd figured out that a network rule was actually denying that the flow he was trying to set up. He just never understood that the egress traffic was processed by network rules first, then by application rules. So real world observation. This is one I actually started experimenting on in the start of the month. Because my approach to how I organize rules was a bit unorganized, and there's been some subtle improvements made to rules collection groups that basically allow us to be much more organized about how we set up our rules now. So when I'm dealing with a customer, I take a very workload-centric point of view to their network. Even though I'm typically just involved in the hub and setting up the core infrastructure for that customer and the security and the governance stuff. The customer I've been dealing with for the last year or so I've been more involved in the workloads than I ever am. So that's gotten me involved in scaling out the firewall rules more than I normally would with a customer. And after a while, when it came to, we were refreshing all the documentation, I realized, wow, it's going to be a nightmare to actually go through some of the firewall stuff because they wanted, workload or ITIL kind of view documentation on everything in a tool called Confluence. And it was just going to be nasty. In the end, we just pointed to the DevOps repos and said, here's your documentation for the firewall rules. It's all in DevOps. But what I found was there's a better way to do it, and that was to basically create one rules group collection for every workload. So I don't know, so you can see it better there. And that gives us a more granular ARM deployment as well. So each of those red boxes is basically an ARM deployment. So I can say I want a rules group collection for workload A. That's a whole ARM deployment of its own. So that could be a config file or parameters file, whatever it is sitting in DevOps. And that rules group collection has DNAT rules, DNAT rules collection, has network rules collections, application rules collection that only deal with workload A. So anything that makes workload A work from a firewall point of view goes into that rules group collection. And that is a single ARM deployment. That could be a single repo. And the people who are responsible for that workload could have control over that repo in DevOps or GitHub or whatever it is. And then can push that configuration down to the firewall policy, which in turn writes through to the firewall configuration. And that child firewall policy is inheriting from parent firewall policy, which again has rules group collections, which are managed then by the central firewall admins. And that's the approach that I'm going to be taking from this month onwards with the Azure Firewall rules configurations. It gives me a much better organized set of rules and much easier to document as well. So let's talk about some of the features. So we'll start off, there's two SKUs of Azure Firewall. There's Azure Firewall Standard, and earlier this month, Azure Firewall Premium became generally available. We'll have a look at those features in a little bit. So Azure Firewall Standard, everything that's in Standard is supported by Premium as well. IP groups is the first thing I'm going to talk about. This is actually a resource that sits outside of Azure Firewall, but it's only used by Azure Firewall. And the idea here is instead of me reusing the same IP addresses or CIDRs over and over in my rules, I can document them once in an IP group and then refer to the resource ID of that IP group in my rules. Now, if I'm doing it through the GUI, I don't need to know the resource ID. I just select the name of the IP group. So that basically means that if I have a rule that's saying I'm going to allow traffic in from a whole bunch of different places, if I need to expand that whole bunch of different places, I don't have to go and edit every one of those rules. I just edit the IP group. And that when I save that IP group, that will start writing into my policy and then into my firewall automatically for me. Now, this is great in some regards. Downside to this is that as soon as I edit an IP group, I've locked the configuration of the firewall. Let's say I have 100 IP groups that I'm updating in my repo because there's been a big network change. I've got to make sure that each of those IP groups is processed sequentially, not simultaneously. So I've either got to have it depends on, or I have to do it if I'm doing it through ARM. I've got to do a copy loop that is sequential instead of synchronous. So you've got to be careful about that one. That's a common one where people are doing IP groups at scale for the first time and they're doing it through code. And the first one works and the other 99 fail. And they wonder why that is. It's because the configuration of the firewall is basically locked. Think of it as being like a database record. Cool thing we have in the rules is tags. And there's two different types of tags, service tags and FKDN tags. So if you're dealing with a third-party firewall, typically when you're saying I need to allow outbound access from my Citrix or my Azure Virtual Desktop out to Office 365, do you have to know all the IP addresses of all those different workloads? Probably. In the Azure Firewall, I can deal with a lot of these different things. Office 365 is actually a bad example, but let's say I'm dealing with Azure SQL and other stuff like that. I don't need to know the IP addresses of different workloads within Azure. I just need to be able to use the service tags or the FKDN tags, where Microsoft have abstracted the IP addresses of those services to be a label. And the teams that are responsible for those services use an API that's managed by Azure to register any new IP addresses that they're associating with those services. So if I want to allow outbound access to Azure storage, so storage accounts, I can do that using a tag instead of knowing the IP addresses of those different storage accounts, which could be tens of thousands of IP addresses, let's face it. So makes life easier. Similar concept. This is a bigger version of what's implemented in NSGs, basically. We've threat intelligence. I may have a rule that allows a particular flow because I need that flow. It's required by my application, it's required by the business. But that flow could be abused by an outside IP address. Now that could be an outbound flow, where I have something that's got outbound access to the internet, and maybe that's a known bad IP address. Maybe some kind of command and control for malware has been set up, and the various different threat detection services out there have detected that and are saying, right, that's a bad IP address. Don't allow collections to that IP address from your Citrix, where your Outlook and your web browsers are running. Or it may be that there's an inbound connection coming in. So maybe you've made a silly mistake of denatting out TCP/22 for SSH to your Linux VMs or 3389 to your Azure VMs. And maybe someone's on a rogue IP address and they're brute forcing your admin passwords. But you might have that rule set up. But if you have threat intelligence set up, threat intelligence can alert you about those connections or even automatically deny them using intelligence information that's in the Microsoft Security Graph, which is also populated from third-party sources as well. So it's a cool feature. It has been known to give you false positives. So for example, I've had connection issues to Google Drive and Outlook, or sorry, OneDrive, because at some point somebody put malware on OneDrive. How could they? And then the IP address of that OneDrive cluster or whatever it is was registered as a rogue IP address. So if we need to, we can get an alert. If you're clever, you send that stuff off to Azure Sentinel, you create an incident, you investigate it. If it looks like it's a false positive, you can add the IP address or the FKDN to the whitelist through Azure Firewall policy for threat intelligence to basically override the automatic deny. Automatically, the Azure Firewall is going to send all traffic to public IP addresses to the internet. This is the one scenario where the Azure Firewall does not comply with the routing of the Azure Firewall subnet. So if you have a customer or you are a customer where you are using public IP addresses in your on-prem or your WAN network, you will have to do some extra configurations and basically put in the CIDRs of your on-prem network into the configuration of the Azure Firewall. So you basically say, I've got some non-RFC19 addresses that I'm using privately, and I want to force that traffic through the private interface of the firewall instead of the public interface of the firewall. That's quite common in universities, who are some of the first organizations on the internet and who are given huge blocks of IP addresses and they use them privately. I had that scenario January of last year, and this feature literally appeared the day we started that project. That was quite nice timing and saved our bacon. Otherwise, it was going to be an awkward conversation with the customer. So kind of a cool and important feature. Similar one is forced tunneling. Some customers may say to you that they want all traffic from Azure to be forced to on-prem. Doesn't matter if it's going to the internet. They're going to force it to on-prem. They've got some appliance running on-prem. They want that appliance to see all that traffic. We can enable that using forced tunneling. It's a complicated setup. It's one I would say to you, go and hit Google and do a search for Azure Firewall forced tunneling. But in short, you'll basically deploy a second subnet for the Azure Firewall called the Azure Firewall Management Subnet. And you'll set up a user-defined route on that subnet to say all traffic going to quad 0 will go to internet. Then you'll disable route propagation. So any traffic that's being propagated from your on-prem, also any routes are being propagated from on-prem by a BGP or your local network gateway, won't get sent to that Azure Firewall Management subnet. And then you will force all the traffic from the Azure Firewall subnet to the IP address of that third-party appliance. So DNS, it's a pretty important feature. When I'm talking about Azure networking, I think I've already said this. Routing is important, and my saying about troubleshooting Azure networking is that it's always routing and then it's DNS. If you've been dealing in the on-prem world, it's always DNS. You know, it's the joke amongst Windows admins. When something breaks, it's always DNS. In Azure, it's always routing, then it's DNS, once you verify that it's not routing. And you'd be surprised how often DNS comes up, or you may not be if you're a veteran Windows admin, as being a cause of an issue. So a scenario that you may come across is you have a legacy application running in VMs, and they're connected to the network, and they're routing outbound to the internet through your firewall. And your VM needs to send an email to an SMTP server, and the SMTP server you're going to use is smtp.office365.com. So you set up a rule in your firewall to say, yep, allow traffic out to the IP addresses of that. Ooh, what are the IP addresses of smtp.microsoft.com? Well, the first thing we can do is we can say, right, we're going to configure something called DNS proxy. And that's basically where we're going to say, we want this VNet or this NIC to use the firewall as its DNS server. And automatically, the firewall is going to forward any DNS queries it receives from that VNet or from that NIC. So if my VM goes, I want to send something on TCP25 to smtp.office365.com, that DNS query is going to hit my firewall. And then my firewall automatically is just going to forward that to Azure DNS, which will then resolve it, send the response back to the firewall, which caches the response, and then sends that response back to the VM. Now both of those devices have resolved smtp.office365.com to the same IP address. Because without that DNS proxy, they could both get different IP addresses. And when the server then tries to send the traffic to the IP address, the firewall will go, whoa, 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 I don't know what that is. I've got a different IP address. You're not going there. So with the DNS proxy, they both have the same IP address. Now, you may need to be able to resolve private IP addresses as well using your firewall. So for example, if you're running Windows Active Directory in your network and your VMs in Azure are Active Directory members, you will need to be able to resolve internal DNS names. So you can use the DNS settings feature in the firewall and forward your DNS requests to your internal domain DNS servers instead of to Azure DNS. And I have that a couple of bits that covered in a little bit as well. IP groups, I've already talked about this one. We're backing away from using IP groups now because if we use IP groups, we will actually use a lot of them. And I mentioned that if we have a lot of IP groups and we have updates to multiples of them, if we're not really careful and create a lot of complexity, the first one will succeed and the rest would fail because they would be processed simultaneously. So IP groups kind of seems like a great idea, but just how it's implemented, we just found we don't like it because it just doesn't scale. If you're dealing with a very simple configuration, IP groups is going to be fine. If you're doing this stuff manually, IP groups is going to be fine. But if you're doing it as code, IP groups, just really, really careful about how you do IP groups. DNS. I've said DNS is important. This is basically how we configure DNS. So we have the VNets use the Azure Firewall as their DNS server. Now, under the covers, remember the Azure Firewall is highly available virtual machines in a supporting region. They're even across different availability zones, so different physical data centers. with different power, different public network connectivity, different cooling, etc., and on different storage clusters. Then the Azure Firewall is pointing to the domain controllers. So now the VMs running in my different workload subnets can resolve through the Azure Firewall internal FQDNs as well. And then the domain controllers split that traffic in two different directions. We may have conditional forwarders set up to point to 168.63.129.16. If you've done a lot of Azure networking, you will recognize that IP address as being the Azure Virtual IP address. And basically, a lot of services in Azure make themselves available to virtual networks through that IP address. They basically NAT through that IP address. So if you send any UDP 53 traffic to 168.63.129.16, you are basically hitting Azure DNS. So you're hitting public DNS and you're hitting private DNS. The private DNS is important because that's where we store the DNS resolution for private endpoint. So if I'm setting up Azure SQL, storage, key vaults, any of that good stuff using private link or private endpoints, which is the instantiation of private link, then I need to be able to resolve the new FQDNs of those workloads, because the old FQDNs actually point at the public IP addresses, not the private IP addresses. And then, of course, my domain controllers need to be able to have their default forwarders to go to whatever route they take to the internet, whether that's directly or through a DNS proxy or whatever it is in a DMZ. Right, the premium features. How are we doing on time? Wow. Then you need to speed up. So the premium SKU, it's GA since earlier this month. The compute cost is roughly 40% higher. The throughput charge is the same. There is no smooth upgrade process. Today, you basically have to redeploy your firewall. If you do a Google for how to back up and restore Azure Firewall, you should hit my blog. And I'll show you how to do it without losing any configuration. And you'll do it as quick as you can actually do it. You basically back up the ARM configuration and redeploy the ARM configuration with one minor tweak. You just change the SKU. And then you're going to have to create your Azure Firewall policy with the premium SKU as well. TLS inspection. The TLS inspection basically allows the firewall to crack open HTTPS traffic. And the way it works is it intercepts the outbound or the east-west traffic, does the request on your behalf to the external or the internal service, receives the response, and then re-encrypts it using a certificate that the firewall now has that's trusted by your internal clients. This makes a number of improvements. It's a basic critical feature for IDPS, so intrusion detection prevention system. It's required for URL filtering of HTTPS traffic, and it improves how threat intelligence works as well. Basically, you need to be able to see inside the HTTPS traffic to be able to understand what it actually is. Second feature is IDPS, intrusion detection prevention system. And this is where we can enable basically a spy in the firewall to look at the traffic that's passing through the firewall and is allowed to pass through the firewall to look for malicious activity. So looking for things like known malware, known hack attacks, known probing from things like Metasploit, and automatically blocking them, even if the flows are allowed. So this is where you start getting clever and dealing with those ransomware type things. If it's a known form of attack and there's a bit or a byte sequence that's been programmed into the threat intelligence database, which apparently is updated like something like 40 to 50 times a day by Azure Firewall, then this thing will automatically alert and optionally deny that traffic. And again, there's a whitelist feature for this as well. URL filtering, this is an improvement over FQDN filtering. FQDN filtering that we are able to do before in the standard SKU basically allows everything to and from google.com. But what if you want to block google.com/news or bing.com/travel guide? URL filtering allows you to do this. Again, really need to be able to crack into the traffic using TLS inspection. Web categories. This is going to be important if you're running Azure Virtual Desktop or Citrix in the cloud, or using Azure Virtual WAN and you have your on-premises locations routing to the internet via Azure Firewall. Web category filtering allows you to block unwanted types of content. So if you want to block pornography, if you want to block gambling, if you want to block everything and only allow certain business-related stuff, you can do that using this. Now, I'll come back to that in a second, and I'll come back to it right now. It works, but it's very immature. This isn't WebSense or whatever WebSense is called these days. It does work. It's just you can't override the categories. The reports don't exist. You will have to go and create them. Now, you can create them. I created a couple today as a bit of an experiment using workbooks. If you want to make them a bit prettier, you could use Power BI. And it does not record who attempted to reach a site. It only records the client IP address. Now, in some countries, that actually meets legal requirements. Because I've had a situation where I was running these web filters in the past, and we actually had to deploy dedicated web filters for some countries to turn off user identity logging. Because the firewall isn't plugged into your Active Directory, it's not a true proxy. It doesn't understand identity the same way as a proxy would that's plugged into an Active Directory. But to me, it feels more like a proof of concept than a minimally viable product. But the one thing I can say for certain, and I can say honestly, is the Azure Firewall team take a lot of feedback, and they use that feedback to engineer and improve. So I would not be surprised to see if there is adoption and interest in this feature that they will improve it. And it will certainly be a lot cheaper than using some of the third-party products that have been out there for many years. The TLS side of things, TLS inspection, it's kind of complex because it needs certificate. So the recommended solution is in the Windows world, use an enterprise CA to basically deliver a subordinate CA certificate to your firewall that's delivered through a Azure Key Vault. And the firewall will use a managed user identity to authenticate the Key Vault with secret get rights. And we'll use that to re-encrypt the traffic as it goes back to the end user. Possibly the easier thing to set up in a lab is just deploy a self-signed certificate on the Azure Firewall, but then you have to make sure that the clients have it configured using local policy or group policy to trust that self-signed certificate. Monitoring your firewall is going to be important because you need to know what's going on. Cool thing about PaaS means you have a lot of integration, a lot of interesting things you can start doing. So we can send our logs to different locations. We can send them to Log Analytics, which is my preferred one. If you want, you can send it to a storage account where there's basically a JSON blob written every hour for each of the different logs. And that makes it very difficult to understand what's going on. It's not really searchable. Log Analytics is searchable and can keep that data for quite a long time. If you want to use a third-party solution, you could use Event Hub. And from what I've seen, things like Splunk or whatever, cost way more than the likes of Log Analytics. They may have more functionality or whatever, but they are way more expensive. If you're using Log Analytics, that means you can start looking at some of the interesting visualizations you can do with workbooks. To Log Analytics and third-party sources, but I really prefer Log Analytics because we can send that data into a place that we can basically query, whether it's using workbooks, KQL queries, or even connect using Power BI. If you want to make it available to, non-Azure techies or whatever. Though personally, I find the workbooks approach kind of cool. And then you can start pinning those things to a dashboard in the Azure portal, and just give someone who's like a security operator or whoever, or an auditor access to that, and that's all they can see. So that you tell them sign into the Azure portal, they sign in, and that's all they see. Is that stuff. Or you can just set them up in Power BI or whatever. And you can set up scheduled query alerts for things that are logged into Log Analytics, like threat intelligence alerts or IDPS alerts. And then, of course, once that data is in Log Analytics, you can start feeding that into Azure Sentinel, so Microsoft Security Information and Event Management solution. And then you can start getting really clever, because that's going to have, source IPs and destination IPs for lots of different events that may be correlated. And it can tie that together using Unified Entity Behavior Analysis, or UBA. So NSG flow logs, the Azure Firewall log, Windows Firewall logs, all may show the same connections. And there may be other things that are then tied to those IP addresses as well, like malware infections that are picked up by Defender. And that's logged up with an IP address. And you can start building an investigation using Sentinel for that stuff. So troubleshooting tips, you're gonna need log analytics. Realistically, while you can use other solutions for your logging, log analytics, in my opinion, is the only way to go. If you aren't familiar with workbooks, or you just want a quick start, the Azure Firewall team give you a pretty good workbook. I have colleagues who prefer to do the queries through a workbook rather than going in and opening up log analytics and writing Cakewell queries. Personally, I prefer doing the Cakewell query. I save it and I reuse it. And the Azure Firewall team give you a bunch of samples through log analytics as well. So if you go into log analytics, go into logs, and I think it's under queries and then resource type and select firewall. That's where you'll see there's like 5 or 6 example queries, which you can then start customizing yourself. And it gives you very quick access to the information at that point. Get used to searching the logs, but then understand that there's different logs. So you have the network log, you have the DNAT log, you have the application log for your different rules types. So you need to remember there's 3 of those and understand the processing order that I talked about earlier. UDP and TCP connections are different. So for those of us who did computer science, we will hopefully remember the difference between connectionless and connection-oriented communication protocols or transport protocols. So UDP is connectionless, which basically means that there needs to be a rule to allow it in and a rule to allow it out, because it's stateless. So it doesn't work with stateful inspection. And TCP is stateful because it's connection-oriented. So a rule will automatically allow the response. But that can introduce interesting scenarios if you haven't dealt with the next bullet point, which is making sure that the ingress traffic from on-prem is forced through your firewall using routes or user-defined routes on your gateway subnet, and that your spokes or your subnets in Azure are forcing traffic to on-prem through the Azure Firewall. So the next hop is basically the Azure Firewall for your Azure spokes or subnets. And if you end up with split routing, TCP can get in a bit of a tizzy, and the Azure Firewall can get in a bit of a tizzy, and that can be hard to figure out. So understanding and controlling your routing is important. And then don't always blame the firewall. Most people do. It's the first thing they jump to. Oh, Microsoft Firewall, it must be at fault. It's just subliminal. They just automatically just go there. Don't rule out the NSGs. Don't rule out the on-prem firewall. You'd be amazed. You set up this lovely Azure deployment. You set up the express route or the VPN connection. Someone tries to RDP into a VM. They can't RDP. They blame the Azure Firewall. The rule's not there. In my deployment, the rule's there. It's part of the standard deployment. What's not letting it? It's the on-prem firewall, because they're not allowing RDP or SSH out from their on-prem network to this new network range, and that's outside their WAN. And of course, there's the guest OS firewall, which may also be the PaaS firewall. So I may have an Azure SQL database with private endpoint, and it's got a firewall enabled on it, and it's not allowing the connection in from my VMs or my on-prem network or whatever it is, even though my firewall is allowing the flow through. Next one, I've seen this happen once, and this is one to watch out for with legacy applications, and this is snap port exhaustion. This is not just an Azure Firewall thing. This is actually an Azure load balancer thing that can affect not just Azure Firewall, third-party firewalls, but also other things like app services. Basically, we have a resource that's trying to make an outbound connection to the internet through a load balancer, and that load balancer has an IP address. That IP address allows a limited number of outbound connections, or SNAT connections, as they're referred to as in the firewall world. If you have badly written legacy code, the limited number or pool of snap ports that are available on that single IP address can be eaten up in seconds. And then your firewall basically goes offline until those connections time out. So the solution to that is add more public IP addresses. Now, if you're clever and you're planning in advance for this, you will actually deploy an IP prefix. It's a feature in Azure that allows you to reserve a consecutive set of IP addresses as a CIDR block. And then you can pull from that when you need a new public IP address. So you can basically say this CIDR of addresses is going to be the public IP address range of my firewall, but I'll only pick from it when I need it. Now, there is a downside to this, which is if I have more than one public IP address on my firewall, I can't predict what public IP address is used for the outbound connection. I can configure the inbound DNet rules to be pinned to a single IP address. In fact, they have to be. But my outbound connections cannot be pinned. So they'll randomly go out to those public IP addresses. So if you have some third party or external or partner who's expecting connections from you, and they're going to set up firewall rules to only allow connections from you, IP prefix is the way to do it, because you can basically say to them, this is my CIDR, this is always going to be my firewall. I may expand it and shrink it as I require, but if you're setting it up to the CIDR, it's always going to be me, because that prefix has been reserved for me. More tips: use Azure Firewall Policy. Stop using the firewall directly if you're doing it at the moment. Firewall Policy is where, I was about to say the future is, but it includes the last year. So all the new features that have been added in the last year are only in Firewall Policy. As I said earlier on, organize your rules based on your workloads. Come up with a naming standard and use that same naming standard for your rules in your NSG rule names as well. So that makes documentation easier, it makes troubleshooting easier as well. The day you deploy, the minute you deploy that Azure Firewall, enable logging to log analytics and start playing with the data. Start using those sample queries that are in there. Use the workbook from Microsoft and start getting familiar with how to find different things that are going on. And start playing around with it. See how threat intelligence is doing stuff. See how the network rules block and allow stuff. See how the application rules block and allow stuff. Play with the web category stuff and see how that works. And then start creating your alerts through your monitoring. So start looking for too many denies happening. Set up an Azure Monitor alert for snap port utilization. Set up alerts for threat intelligence denies or IDPS denies if you're using the premium SKU. And start feeding that data into Azure Sentinel, where you start creating your incidents and your investigations. Last few slides.